The last session we were discussing questions related to reversible and redox reaction, and we have discussed around 15 questions and then 15 onwards now. Question 16, silver chloride reacts when it is exposed to a light. Which row shows what happened to silver in this process? So what happened? This is a photochemical reaction. So in this photochemical reaction, a silver chloride, because of the light, the silver ion gain electron and turn into silver atom. That is how the photographic plate is developed. A photographic plate is having a coating of silver chloride, but when the light falls, the silver ion turn into silver metal, so it will turn gray or black. So when we check the options, so silver ion is there, it gain electron, it turn into silver atom, and whenever something gain electron, as we know, oxidation is a loss of electron and reduction is a gain of electron. So as it gain silver ion is gaining electron and turn into silver atom. So what we call this change, we call that as reduction, because reduction is a gain of electron. That's why D is the right answer for question 16. Question 17, which is related to reversible reaction. The following reaction has reached equilibrium in a closed system. Sulfur trioxide react with oxygen to give sulfur trioxide. The reaction is exothermic. Which row shows the effect of increasing the pressure on equilibrium mixture? If we increase the pressure, the rate of the reaction is directly proportional. When we talk about the rate or the speed, the factors which affect the rate, that is temperature, the concentration of the reactant, the temperature, the pressure, surface area, and catalyst. So these are the factors which affect or which alter the rate of the reaction. And shifting of equilibrium only depends on temperature, depends on the pressure, and depends on concentration. So these are the three factors which can shift the equilibrium. So first thing, we're increasing the pressure. Whenever we increase any of these quantities, like if we increase the concentration, if we increase the temperature, pressure, surface area, or catalyst, then the rate of the reaction will increase. So first thing, the rate of the reaction increase. Then when we increase the pressure, how the pressure affect the shifting of equilibrium? Whenever we increase the pressure, equilibrium will shift towards side where less moles are there, less particles. And when we decrease the pressure, equilibrium will shift towards side where more particles are there, more moles are there. So in the question, we are increasing the pressure. So when we work out the number of the moles, 2 plus 1, the total moles 3 are there, total particles of the reactant 3, and total particles of the product 2. So increasing the pressure shift the equilibrium towards side of less moles, so it will shift towards the right hand side. So as the equilibrium will shift towards the right hand side, the percentage of sulfur trioxide will increase and amount of oxygen and sulfur dioxide will decrease. So amount of sulfur dioxide will decrease and amount of sulfur trioxide will increase. So the option which it matches with, that is A. Is it clear? Question 17. Another question, BiCl3 react with water which form a white precipitate. The term precipitate means when we mix two solutions, if a solid is formed, we call that as precipitate. So as you can see, Aqueous plus liquid give a solid. So whenever a solid is formed, that is known as precipitate or PPT. In the question, which statements are correct? The reaction is reversible. The reaction is reversible. That's true because as you can see the arrows, whenever reversible reactions are there, then the arrows are pointing. Reactant can form a product. Product can form back the reactant. So that is right. When hydrochloric acid is added, more white precipitate form. This BiOCl is a white PPT, white solid. But if we add HCl, if we add more HCl, so what happened? Equilibrium will shift towards the left hand side. So if equilibrium will shift towards left hand side, amount of the white precipitate will decrease. It will not increase. That's why 2 is not the right statement. When we check the third statement, when sodium hydroxide is added, more precipitate form. So when we add sodium hydroxide, this you will study in next topic, which is about acid and alkali. So sodium hydroxide is a base or alkali, and alkali can react with acid. Acid and alkali base can react with each other, and when they react with each other, so amount of the product will decrease. If amount of a product decrease, where the equilibrium will shift? Equilibrium will shift towards the right hand side. So as a result, the amount of the white precipitate will increase. So an aqueous sodium hydroxide is added. When we add sodium hydroxide, it will react with HCl, so amount of HCl will decrease. So whenever amount of product decrease, the equilibrium shift to balance. So equilibrium shifted towards right, so more product will start to form. So statement 1 and statement 3 are correct. That's why C is the right answer. In the question, an excess of iron 2 chloride is added to manganate. So iron 2 chloride is there, Fe2 is added to manganate, in which Mn is plus 7. So when this reaction will occur, iron will turn into iron 3 and Mn plus 7 will change to Mn2. As we discussed, uh, specific colors you have to learn specifically for Mn plus 7 and Mn plus 2. So when this reaction occur, Fe is plus 2, iron 2, they mention here iron 2 chloride or iron 2, reacted with Mn7. So when the reaction occurs, the iron will turn into iron 3 because it will lose electron, and Mn plus 7 will turn into Mn plus 2, so it gain electron. When we work out the changes here, iron is plus 2, it changes to iron plus 3. So if iron plus 2 change to iron plus 3, the oxidation number increase. And whenever oxidation number increase, what we call this change as oxidation. So this change is known as oxidation, or this substance is known as reducing agent. So iron 2 is acting like a reducing agent. When Mn is plus 7, it turns into Mn plus 2. So here the oxidation number decreases. If oxidation number decrease, we call this change as reduction. And whenever reduction happen for that substance, we call that as oxidizing agent. What about the color? Only the color which you have to learn for Mn plus 7, that is purple in color, and Mn plus 2 is colorless. So when we check this statement, the purple color disappear. That's true because originally Mn plus 7, it turned into Mn plus 2. So purple color will disappear, or there will be no purple color. That's true. Iron 2 is reduced to iron 3. That's not reduced, that is called oxidation. So this is not correct. Mn7 ion are oxidized to Mn2 ion. That's also wrong. Mn7 ion are not oxidized, they are actually reduced. And potassium manganate 7 is oxidizing agent. Because it is reduced, so acting like an oxidizing agent, so it is also true. So the correct statement is 1 and 4. That's why B is the right answer. Is it clear? Discussion? Then question 20, methanol is prepared by a reversible reaction. Reversible reaction means the reactant can form a product can decompose and form back the reactant. Which condition produce the highest yield of methanol? Yield of methanol, whenever you are talking about yield, it refers to amount of the product. So this is a term which is used for amount of the product, so which is giving the highest yield or greater amount of product. The reaction is exothermic. Whenever a reversible reaction is exothermic, if we increase the temperature, equilibrium will shift towards the left hand side, and as the equilibrium will shift towards the left hand side, the yield will decrease. But for exothermic reaction, if we decrease the temperature, equilibrium will shift towards the right hand side, and as equilibrium will shift towards the right hand side, the yield will increase. So we want to increase the yield, the highest yield. So exothermic reaction, for temperature, what we should do? We should decrease. And what about the pressure? What is the effect of the pressure on position of equilibrium? If we increase the pressure, equilibrium will shift towards the side where less particles are there, less moles. And if we decrease the pressure, equilibrium will shift towards side where more particles are there. So in this case, 1 and 2, so there are 3 particles of reactant and only 1 particle of product. So what we should do, we should increase the pressure. When we increase the pressure, equilibrium will shift towards side where less particles, so it will shift towards right hand side. So pressure should be increased and the temperature should be decreased. So pressure should be high and the temperature should be low. That's why C is the right answer for this. The thermite reaction can be used to produce iron from its iron 3 oxide. So this is the equation. Which statement about the reaction is correct? So first we have to sort out aluminium is reacting with, so aluminium is there, 2 aluminium atoms reacting with iron 3 oxide give iron plus aluminum oxide. So when oxygen is involved, we can use the oxygen to work out whether it is oxidation or reduction. First it is aluminum and then it turned into aluminum oxide. So if aluminum turned into aluminum oxide, it means there's a addition of oxygen, and whenever there's an addition of oxygen, we call this change as oxidation. And for substance which oxidation happen, that is a reducing agent. So aluminum is actually a reducing agent. For iron 3 oxide, it turned into iron 2. So because oxygen is removed, removal of oxygen, and removal of oxygen is known as reduction, or that substance is known as oxidizing agent. So the question is, which statements about the reaction is correct? When we check the statement, aluminum is oxidizing agent. Aluminum is not an oxidizing agent, it is a reducing agent. Aluminum is less reactive than iron. If we write the reactivity series, we have potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead. So when you check, aluminum is not less reactive, aluminum is more reactive. And because this reaction occur, so if this reaction occur, it shows that aluminum is more reactive. Aluminum is able to displace iron from its compound. Electrons are transferred from aluminum to iron, or aluminum is losing electron. That's true because oxidation is a loss of electron. So aluminum will lose electron. For aluminum, oxidation happen. And iron, in the iron 3 oxide is reduced. So that is also correct. That iron 3 oxide, the iron here is reduced, as you can see. It is a loss of oxygen or removal of oxygen. So statement 3 and 4 are correct. That's why option D is the right answer for question 21. Is it clear, this example question? Then the equation for reaction between zinc and copper 2 oxide is shown. So when we write the equation, we have zinc. When oxygen is involved, we can write identify in terms of oxygen. So zinc turn into zinc oxide, addition of oxygen. We call that as oxidation. And copper oxide turn into copper metal. So removal of oxygen, we call that as reduction. And for substance which reduction happen, it is an oxidizing agent, and substance which oxidation happen is a reducing agent. So they're asking which is oxidizing agent. So oxidizing agent is copper oxide. And which is a reducing agent, substance which oxidation happen is a reducing agent. So zinc is a reducing agent. So copper oxide and zinc, so it matches with option B. Now the structure question. Hydrogen can be manufactured from methane by steam reformation. This process is known as steam reformation. The reaction is carried out using a nickel as a catalyst at a temperature between 700 and 1100 degrees centigrade using a pressure of 1 atmosphere. The forward reaction is endothermic. What is meant by the term catalyst? So it's of 2 marks. How you will score 2 marks? So catalyst is a substance which alter the rate of reaction without chemically used up. So the substance which speed up the reaction, alter the rate of the reaction. So substance speed up the reaction, that is 1 mark, and without chemically used up, or chemically unchanged, that will give you the second mark. Like before the experiment and after the experiment, the mass or amount of the catalyst won't change. That's the meaning of chemically does not use up. Suggest 2 reasons why the temperature lower than 700 is not used. Like why we did not use temperature less than 700. So there are 2 reasons. Like example, if the temperature is low, the reaction will be, rate of the reaction, speed of reaction will be slower. And the second thing, the reaction is, this is a reversible reaction, and the reversible reaction is endo. If a reversible reaction is endo, if we use a high temperature, where the equilibrium will shift, towards the right hand side, and as the equilibrium will shift towards the right hand side, the yield or the amount of the product will increase. And if the reaction is endothermic, reversible reaction, and we decrease the temperature or we lower the temperature, equilibrium will shift towards the left hand side, and the yield or the amount of the product will decrease. So 2 reasons why the temperature lower than 700 is not used. Number one, it if low temperature is used, the temperature less than 700 will reduce the rate of the reaction, the speed of the reaction, and the rate of the reaction as well. So both things will be reduced or both things will be decreased. Suggest one advantage of using a pressure higher than atmosphere. So if you use a high pressure, look, if we use here 1 mole and 3. So there are 2 moles of the reactant and there are 4 moles of a product. So if we increase the pressure, equilibrium will shift towards the left hand side, but that is a disadvantage, like the amount of the product will decrease. But what is the advantage? As we know, the rate of the reaction is directly proportional to concentration, the surface area, the temperature and the pressure. So if we use a high pressure, will increase the rate. But what is a disadvantage? The high pressure in this example will shift the equilibrium towards left hand side, which reduce the yield. Yield means amount of product. Like you don't get too much product. Reaction will be faster, but the amount of the product which you will get will be smaller. Is it clear discussion that how the pressure is affecting the equilibrium as well as the rate of the reaction? Any doubt till this point? Then another question. Question 24. Solution of iron 2 chloride. So we have iron 2 chloride and iron 3 chloride were added to potassium iodide and potassium manganate. This is the table. The results are shown. So what type of substance cause a potassium iodide solution to turn from colorless to brown? So as you can see here, potassium iodide means it contains iodide ion, and iodide ion is colorless. And it turned from colorless to brown. So how it turned brown? It means the iodide ion, it turned into iodine molecule. That is why it turned into brown. So what is this change? Iodine is -1, it turned to 0. If -1 turned to 0, oxidation number increases. If oxidation number increase, what we call this change? We call this change as oxidation. So for iodine, like this change when potassium iodide changes into a brown substance. So basically we want to do oxidation. So if we want to do oxidation, what type of substance cause the potassium iodide to change from colorless to brown, or what substance can oxidize potassium iodide or iodide ion? So what we will write as oxidizing agent. Like what substance is causing that? Like which substance iodide ion should react? Which substance iodide ion should react to turn into iodine molecule? So because for iodide ion, it is oxidation is happening as it turn into iodine molecule. So what we need an oxidizing agent. Same way, what type of substance cause potassium manganate 7 to turn from purple to colorless? So how potassium manganate 7, Mn is +7 turn into Mn +2. So this change is reduction. Oxidizing agent is a substance or a chemical or a reagent. This is the name of like oxidizing agent is a general term. And in a reaction, different reaction, you have different types of oxidizing agents. So if we want to convert Mn7, which is purple in color, and Mn2 is colorless. So this change is reduction because oxidation number decreases, we call reduction. So what we need to carry out the reduction? So to carry out the reduction, we need a reducing agent. So what type of a substance can cause potassium manganate to turn from 7 to 2? So we need a reducing agent. Then which ion in iron 3 cause the potassium iodide to turn from brown to colorless? So which ion is causing? Even answer is given in the question. Iron 3 is there because iron 3 ion is causing this iodide ion to turn into iodine molecule. And which ion in iron 2 chloride cause potassium manganate to turn from purple to colorless? So iron 2 ion is causing that to change. Basically what happened, like you have iodide ion, it is reacting with iron 3 and it turn into iodine molecule plus iron 2. This is the equation. So when we work out this equation, iodide ion is changing into iodine molecule. So oxidation number is increasing. We call that as oxidation. And iron 3 turn into iron 2. So oxidation number is decreasing. We call that as a reduction. And for substance which reduction happen, that is acting like an oxidizing agent. So in this question they're asking which ion in iron 3 chloride. So which of the ion in iron 3 chloride is causing the iodide ion to turn into iodine molecule? So basically iron 3 is causing the change of iodide ion into iodine molecule. And same thing, which ion in iron 2 chloride causing the potassium manganate turn from 7 to color Mn7, which is purple, to colorless? So iron 2 ion is causing that change to turn from purple to colorless because Mn7 will gain electron and iron 2 will lose electrons. Then this question is about nitrogen and some of its compound. Nitrogen in air can be converted to ammonia by a Haber process. State the temperature and pressure for Haber. That is, this part is related to chapter 12. So you will learn that temperature and pressure. I'm writing the values directly, but you have to memorize, but not now in this chapter. You will memorize in chapter. So another chapter, so it's 450. The temperature is about 450 degrees centigrade and the pressure is 200 atmospheric pressure. Name the catalyst used for Haber process. So again, that you will learn in a Haber process, the catalyst used is iron. The ammonia produced in a Haber process can be oxidized to nitrogen 2 oxide at 900 degrees centigrade. The reaction is exothermic. We have to balance the equation first. Whenever you are balancing the equation, you should start with oxygen followed by hydrogen at the last other element. So we try to balance oxygen first. And as you can see clearly that if there is 4NH3 and this is the only compound contain nitrogen, so if I put 4, so nitrogen is balanced. Then what about oxygen? And 4 multiplied by 3, 12 hydrogen. So if I need 12 hydrogen here, so if I put 6, hydrogen is also balanced. 6 multiplied by 2, that make 12. Now what about oxygen? 4 plus 6, 10. So I put 5, so oxygen is also balanced. Because ammonia was the only compound contain nitrogen and hydrogen directly. That's why I first balances nitrogen and hydrogen. But it's up to you. Any of the compound can be balanced. It's up to you what you find it convenient. Balance that first. Suggest a reason other than the cost why the temperature greater than 900 is not used. So why we don't use a very high temperature? They mention the reaction is exothermic. Whenever the reversible reaction is exothermic, when we increase the temperature, equilibrium will shift towards the left hand side and the yield, the amount of the product will decrease. And if we decrease the temperature for exothermic, equilibrium will shift towards the right hand side, or the yield or the amount of product will increase. So why we did not use a high temperature? Because if you use a high temperature, then what happened? The yield or the amount of the product so yield or the amount of the product will decrease. That's why we do not use a high temperature. Suggest a reason why the temperature less than 900 is not used. Like why we did not use too low temperature. So if the temperature is too low, the reaction rate or the speed of the reaction rate will be slow at low temperature. So if the temperature is low, the rate will be slower. If the temperature is high, the rate will be faster. So this is the optimum temperature, like to have a better rate as well as the yield. Nitrogen 2 oxide can be reacted with oxygen and water to produce nitric acid. As the only product, write equation for that. So nitrogen 2 oxide, this is a formula for nitrogen 2 oxide, reacted with oxygen and water to produce nitric acid. The formula of nitric acid is HNO3. The equation, whenever you write the equation must be balanced, but you don't have to memorize right now because it is related to acid topic, that is the next chapter. So it will form 4 molecules of nitric acid. In question 26, ammonia is also made when ammonium carbonate decomposed. The reversible reaction is there, and the graph shows how the temperature, a graph shows how the yield or amount of a product or ammonia changes with the temperature. What is meant by the term equilibrium for a reversible reaction? So the term equilibrium means that when rate of the forward reaction, the rate of the forward reaction equal to the rate of backward reaction and no change in concentration of reactant or product. So amount of the reactant and product won't change, and speed at which the formation and the decomposition occur will be same. Use information from the graph, explain whether the reaction is endothermic or exo. So how to identify it's an endothermic or exothermic? As you can see, at 300 we are getting more product. At 100 we are getting smaller product, like small. So it means if we are increasing a temperature, we are getting more product. So when we increase the temperature and we get more product, it means the reaction is endothermic. Because for an endothermic reaction, increase in temperature shift the equilibrium towards the right hand side. So we'll get greater yield. State and explain effect of increasing the pressure. So what is the effect of increasing the pressure? As you can see, the number of, here we have no part, this is solid, so we don't have any particle of a gas. Here we have 2 plus 1 plus 1, so there are 4 particles. So when we increase the pressure, equilibrium will shift towards the left hand side. So the yield will decrease. The rate of the reaction will increase, but the yield of the reaction will decrease. So effect of pressure, increase in pressure shift the equilibrium towards the side of less moles or less particles. In this reaction, it will shift towards the left hand side. And as it shifts towards the left hand side, so the yield will decrease. Whenever equilibrium shifted left, the yield or the amount of product decrease. Equilibrium shifted towards right, the yield or the amount of product will increase. Question 27. During electrolysis, copper atom turned into copper ion. So this change is oxidation because it's a loss of electron, and copper ion turned into copper atom, so this change is reduction. The question is, which species reduce during the electrolysis? So copper ions are reduced, and what is the reason for that reduction? Because they gain electron. Whenever anything gain electron, we call that as reduction. In question 28, sulfur dioxide is converted into sulfur trioxide. What is the symbol this means? It means it is a reversible reaction. What is the catalyst used? Again, you have to learn this catalyst for sulfur trioxide. It's called vanadium pentoxide, but not now. You have to learn later in topic of sulfur. Why is catalyst used? The purpose of the catalyst is to speed up the reaction. If the temperature higher than 450 is used, what will happen to amount of sulfur trioxide? So because the reaction is exothermic, and if we use a high temperature, then what happens? Increase in temperature shift the equilibrium left hand side for exothermic reactions. So the yield will, if the temperature is more than 450, the yield will decrease because the equilibrium shift towards the right hand side. And give a reason why the temperature, well, like why we did not use very low temperature. If you use very low temperature, then what happened? The rate of the reaction will be very slow. So these are some questions related to topic reversible and redox reaction.